When solving a quadratic equation by graphing, first we need to put the quadratic equation in standard form. And so first we need to recognize that x squared minus 6x equals minus 9 or negative 9 is not in standard form. And so in order to actually put this in standard form, we need to make sure that, or we need to look for our leading coefficient. We want to make it positive, and we want to move everything to the side of the equation where the leading coefficient would be positive. Sometimes that's not possible, but it's what we're going to do. So we're going to add 9 to both sides. And then when we add 9 to both sides, we get x squared minus 6x plus 9 is equal to 0. These two cancel. And now we have our equation in standard form. And in order to graph this, we're going to use the things that we used before. So this is a 9, our a, or our leading coefficient, our a, is greater than 0. Therefore, this parabola is going to open upwards. So we know that right away. And then the next thing we're going to look at is the fact that because the parabola opens upwards, we know that our vertex is going to be a minimum. So we know that right off the bat. Next thing we're going to do is we're going to find the axis of symmetry. And that we need to know this equation for the axis of symmetry is x equals minus b divided by 2a. And so remember, our a is the coefficient of the x squared term, b is the coefficient of the x term. And so we have minus a, so minus b, excuse me, which is minus 6. Always put mine in parentheses just to remind myself that I'm plugging in. Divided by 2 times a, which is positive 1. So I get positive 6 divided by positive 2, which is 3. So that means my axis of symmetry is 3. Now, for my axis of symmetry, I could figure out that this dotted line, again, this dotted line is not part of the graph. It's just a guide to remind me where the axis of symmetry is and to let me know that the graph is going to be the same on both sides. So if I were to plug in this x value into my equation, I should get my y value out. And again, when I'm graphing this, really what I'm graphing is x squared minus 6x plus 9 is equal to y. And so when I plug in this x value, I get 3 squared minus 6 times 3 plus 9. 3 squared is 9. And so I have 9 minus 18 plus 9. And lo and behold, I actually get 0. So my actual point is 3, 0. 3, 0 is right here. And that's actually not only my vertex, which is the minimum point that I could possibly have, it's also my root. Because when I plug in 3, I get out 0. And when y is equal to 0, that gives me the solution of this equation. So since that's my minimum point, this graph can actually go lower. It can actually go further below the x-axis. It's the only time this graph actually touches the x-axis. And so I'm going to pick some points on the other side. I recognize that my y-intercept in this case is positive 9. So that's here, because that's the constant term. So at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's up here. Since this is 3 spaces away this way, I know there's a mirror image point since this is symmetrical. 3 spaces away from my axis of symmetry on the other side at the same height. 3 spaces that way. And so when I draw this, I should recognize that my graph, which has the same form as the parent function, y equals x squared, only touches the x-axis at one point, and that point just also happens to be my vertex. This means I have one unique solution for this graph. Okay? And so this is the one unique solution.